Welcome in this video. I am David Ballon, technical responsible for CosiMate development. The aim of this video is to show the possibilities offered by CosiMate beyond the cosimulation aspect. More than just connecting models from different platforms to enable simulation at system level, here is a demonstration of what CosiMate enables in terms of system development. The example that I will show you does not intend to show complex problems, but more to focus on methodology. When it comes to a model-based development, each simulator provider has its own means for tuning their models and make them as accurate as possible. Nonetheless, this will never cover the integration with other models from other platforms, and that is what CosiMate can cope with. This example cosimulation is quite simple and represents an active car suspension cosimulation. We start from a Sabre model representing the mechanical suspension coupled with a Simulink model representing the PID control. Regardless of the representativeness of this cosimulation, we aim at tuning the entire system by checking the cosimulated model's response while modifying one model parameters across repeated cosimulation. In this example, we chose MATLAB as the master of cosimulation. That means that the start of the MATLAB Simulink model will automatically start the cosimulation globally. But let's see it working in real time. So I just have to launch the MATLAB models and I will see the cosimulation running. It's done. Now, in order to achieve parameters tuning, I chose to use the PYD parameters. So all we have to do is loop on this cosimulation while each time modifying the PYD parameters. This can be done by various means, but here I chose to use a MATLAB script. So let's see it working. As you can see, the cosimulation runs as many times as required, while the parameters are modified. And you can see it running and running again, as requested. And see the different outputs here on each simulation. Of course, the result of each cosimulation is saved in a separated result file. So at the end of the cosimulation, you can use your favorite tool to compare the results from each cosimulation. Here I chose CosiMate Scope, which is a CosiMate tool provided with CosiMate. And as you can see the influence of the parameter change between cosimulations. This type of repeated cosimulation offers lots of possibilities, not only for model parametric study, but it can also be used for statistical analysis such as Monte Carlo, etc. But how do I perform such a bunch of cosimulations mastered by one of the simulator with CosiMate? That is what I'm going to show you now. You will see how quick and easy it is to configure such a cosimulation. So let's go back to the beginning. Here are the two models, the two original models, before configuring the cosimulation. Let's start with the Sabre model. We have our own CosiMate library included in Sabre. All we have to do is add the CosiMate port to the cosimulation. Here I just change the port name and I'm adding an output. Once again, changing the name. Then all we have to do is launch the simulation once in standalone mode. Here it is. This will create the interface description file needed by CosiMate. Here, which is an IXD file describing the ports that I've just created. Now we can do the same with Simulink. Change the port names and run the simulation, the standalone simulation, in order to create the interface file. Now the model interface description files are ready. Let's build the CosiMation netlist. Here is CosiMate graphical user interface. To import the models, we just use the file we just created. So we import first the MATLAB interface description file, then the Saber interface description file. And then we connect them to the bus. As you can see, the model parameters such as time step and time and the ports are already automatically imported with the interface description file. Moreover, as I gave the same names for the ports in Saber and Simulink model, CosiMate automatically detected it and connected the ports. If the ports do not have the same name, you will have to connect them manually here. Of course, you can configure your model and your simulation here, and also the netlist. Here I checked the CSV traces file, which allows to record the simulation results, all the data that is passing on the bus during the CosiMation. You can then add your comments and you can modify the simulation parameters until you obtain your final netlist. That's it. And it's ready now. You can check the netlist, see if there is no error, and then you'll launch your first simulation. CosiMate asks first to start the Simulink model. And once started, it asks to start the Saber model. And then you can run the CosiMation. Here it is. Your first CosiMation is done. This is what we call interactive CosiMation, because CosiMation is started from CosiMate and manually. But you may want to start CosiMate automatically from one simulator, and that's what I'm going to show you here. When the netlist was created on CosiMate, CosiMate created a ACN file, which is the netlist file. In order for one simulator to be the master of co-simulation, you must indicate in the simulator the netlist that has to be started, and then set auto start co-simulation to yes. And that's it. Now you can just close CosiMate model, and you can see that you can start the co-simulation directly from the model. The opening of CosiMate is fully transparent, and the launching of Sabre model also. Now for statistical analysis or parameter tuning. As I showed at the beginning of the video, you just have to create a command file with a loop on the master model. That's what I did with MATLAB, with the MATLAB script, but it can be done with any other tool or batch or anything. That's up to you to choose. And then you just have to launch your loop to make your statistical analysis or parameter tuning. Very simple, isn't it? This video showed one of the opportunities given by CosiMate. But there are many others. We do not intend to create just a co-simulation platform, but also to effectively help system developers by providing them easy tools. Thank you for watching this video. Goodbye.